It's fine. We can go now, right? Okay, so thank you everyone for joining. This is Carolina. I am representative of Plurisa, Marketing and Sales. Today we have the greatest opportunity to do a live webinar over machine learning, more specifically to talk about reasons why your chatbot needs natural language processing. We connected with Rohith Pudari, which is an amazing expert on machine learning. So today he will be leading us through this amazing webinar. And Rohith, can you go forward to introduce yourself, please?
Yeah. Hello everyone. I'm Rohit. I worked as a Google researcher for a year on Google Actions platform, which I'll be explaining a bit in the later parts of the webinar. I'm currently a PhD student at University of Toronto with research interests in machine learning for software engineering and privacy preserving AI. That's a quick introduction about me. Um, a bit of a fun fact that if you're using Android, there is a bit of my code I wrote which runs in your phones. So yeah, that's a pretty great achievement, I would say, from my side, saying that there are people in the world using my code. So yeah, that's pretty much my introduction. Uh, shall we begin? Okay. So the proposal for this workshop would be first I'll be going through what NLP is. As you can see in the slides, that NLP is an interdisciplinary field concerned with interactions between computers and natural languages. So it's a sweet spot where computers and computer science and linguistics meet in the universe of ML and AI. So for the daily users, I would say there are many. Uh, for example, personal assistants, autocompletes, your spell checks, or the most famous one, the translate of each language. Uh, so those are the general usages of NLP in which impact in our daily lives. Coming to what's uh, in the business related use cases, where does NLP come into picture and how does that help? So I would like to give two use case scenarios where it can be used in any general business as well. The first one is if you have a bank or a restaurant with like a significant amount of customer orders and complaints, where you're manually handling this uh, by having a call center or a separate department handling all the requests of your customers, which is not pretty efficient in terms of time and labor. So where NLP helps is that you can build a chatbot for your business which can automate all the process of logging your customer orders or complaints, which can heavily streamline and make the team more productive. The second example is the more recent one. Suppose you launched a product, or maybe an example which shows here that Apple launched new iPhone 12. So if they wanted to know, not that they would, but if they wanted to know how their iPhone is being used or what people are thinking about that new product which you launched. So what you can do is rather than manually checking each and every places, each and every social media, they can automate the process of monitoring using sentiment analysis, which is a part of natural language processing, to say to just give you a flow chart saying how many reviews are positive, which how many are negative, and how many are neutral, which can drastically improve your statistics for your next product release as well. So So those are the use cases which say that NLP is definitely useful, and you should, if you have a use case where it can, where a language is a barrier while interacting with computers, NLP is your go-to answer. So, what are the categories of ML? So, there are three main ones. The first one is rule-based systems, which I would say is not used at the moment, which is like which was prevalent, I would say, in 2006 to 2013, 2012 or 2013. Uh, I would say rule-based models are the pretty old model ones, the traditional approach. Then came the boom of machine learning and started with the classical machine learning approaches, which improved NLP, which started NLP as a whole, which gave confidence to people that yes, computers can understand uh, human related stuff like language and can reply us back like a human, hopefully. And then came the deep learning models, which are the latest ones, like GPT-3s, where each and every model is tailored to each specific use case. And I would say if you tune it good enough, it can almost match a human. And in a Turing test, I don't know if many people know of the Turing test. So if you perform a Turing test, that's the ultimate test that uh, a computer is exactly thinking like a human. So going a bit depth, what rule-based systems actually are. These are the ones which rely heavily on crafting domain-specific rules. For example, regular expressions can be used to solve simple problems, not much complex ones, such as extracting structured data. For example, email IDs inside web pages. So, but these are the ones which rule-based systems can help. But these are very less complex. So, as you all know, humans have really complex level of natural languages, and rule-based systems won't help in any way to build models that can reason about languages. So, so the rule-based systems mostly consist of general if and else statements where you have to specify each and every case and say that how to respond. So in theory, in practical, I don't think you can have each and every a use case for each and every word in English. That's just not feasible. So rule-based systems are kind of not used right now for NLP purposes. The next one is the classical machine learning approach, which can be used to solve more challenging problems than the rule-based ones. For example, spam detection. It relies on a more general approach to understand knowledge using handcrafted features such as sentence length or parts of speech tags or the occurrence of specific words. For example, if there is a word of money, which is something related to a money, if the email consists of too many words of money, then it's probably a spam than a real email. So that's how classical machine learning approach works. Then providing these features, all these features created by a human, and then send that to a statistical machine learning model, such as naive Bayes or any model you have, which learns different patterns in our dataset and able to reason about unseen data, which is also called as inference. The problem with classical machine learning approach is that you have to have a very good training data set because the model knows what you give, and it doesn't know if it encounters something which is not in the training data set, and then it won't know what is happening inside. And also, classical machine learning is not complete. One other drawback is it's not completely autonomous. It requires human assistance to extract features in each and every data. So that's a classical machine learning approach, which was prevalent, I would say, 2006 to 2013 or so. That's when deep learning models came into picture. The main goal for deep learning models is to minimize human intervention in decision process as less as possible. So automate each and every place of NLP is the goal of deep learning models. Right now, we are still trying to do that. So uh, the advantage of deep learning models over classical machine learning models is they generalize better, even better. That even if there is some data which is not included in the training data set, then it still gives you a pretty good reason inference out, which using all the training data it had and all the knowledge it gained using that training data. So and they don't need handcrafted features because they automatically work as feature extractors. So you don't have to find each and every feature in the your training data set. The model does that for you. This helps in building end-to-end models with as little human interaction as possible. And aside from the feature engineering part, deep learning algorithms, learning capabilities are much more powerful than the shallow uh, classical machine learning ones, which paved its way to achieving higher scores in many challenging NLP tasks which were considered as impossible in earlier ages, such as machine translation from languages, which was like at least a human was definitely required years ago, which now a machine can easily do translations between different languages. So that's pretty much it about the NLP categories. So next, jumping back a little uh, to understand how actually a computer understands text. To see to get back into how computers understand text, uh, we are also already know that computers only understand numbers. They don't understand characters or words or sentences. And each word is represented in their own ASCII codes. So those are all numbers as well. So the immediate step is to find a way where it the computer can understand text, which was text representations and word level representations. I'll be focusing more on word level ones because it is more widely used and the intuitive ones to start with. So it's much easier to understand the word level ones than the text level ones. So, in the traditional NLP era, before the deep learning approach, which was given when the classical machine learning was done, there was only one basic idea to make a computer understand text, which was one-hot encoding. So, what one-hot encoding is that a sentence is represented as a matrix of shape, n rows and n columns, where n is the number of unique words in the sentence. So it's the vocabulary it learns. It's also called as bag of words. So, for example, each you have a sentence saying that a cat is chased by a dog. Then all the words occurring in that sentence are taken into each row. So a cat is being chased by a dog, which means it would have 8 rows and 8 columns. That's how a sentence was converted into a matrix that's called as one-hot encoding. Uh, Obviously, it had its own drawbacks because it was very memory hungry because each sentence in English lasted a normal general sentence lasted about 15 to 20 words, and it's not feasible for us to have a matrix which is 15 rows and 15 columns long. and most of the columns were zeros because the many words in English are not used more than once in each sentence. So it was huge memory capacity issues, which is also called as huge sparse representation. And the second one, main drawback for the hot encoding is lack of meaning. Is that it converts the text or the words into numbers, but it still doesn't understand what the word means actually means. So that was one another issue, which it can't derive similarities between words such as school or books. If you give words like school or books, a human can understand that those two are related, but a machine will definitely not understand what it will definitely see them as two very different words in one hot encoding method. So that's when, in 2013, researchers from Google, led by Thomas Mikaloff, invented a new model for text representation, which was, I would say, revolutionary and currently used as one of the pioneering models for NLP is called as word to vec. It's a shallow deep learning model which can represent words into vectors and capture the meaning between related terms, such as uh, the words school and books are have the same direction in the same vector. So the computer understands that okay, these two words are similar. They have some similarity in between them. Further research on word2vec built on top of such as Glove, FastX, or the most recent GPT-3 models does use word2vec models inside them. So that's how the progressing the general history from how computers started to understand text and how it currently understands text. So moving on to why do we need chatbots? Can we move on to the next slide? Yeah. Why do we need chatbots? So we have all now seen that how NLP works, how computer understands what language is and what words are, and then now let's see what do we need. Why do we need chatbots? It's just human psychology that we prefer talking to humans rather than saying words such as get water or just like giving SQL queries. So people won't be interested in giving some query just like just to a computer rather than they would prefer talking to a actual human being or an experience as close to talking to an actual human being. That's where chatbots come in. Imagine how boring it would be communicating with each other with just simple commands. Uh, that would be very awkward, I would say, and not interesting as well. So we pass information to humans, and humans tend to speak to humans a lot more than and they enjoy talking to other humans than computers. So that's where the use of chatbot started to save human resources for qualitative tasks and use chatbots for the more automated processes. The better user interactions also happen. Uh, the few advantages are mentioned on the slide. So basically, a chatbot is an agent having a chat interface using which a user can actually talk to the computer program and get the work done. So that's where chatbots come into picture. That's why you need to use chatbots. So next slide. How do you create a chatbot then? Uh, there are different kinds of platforms where you can create a chatbot, such as Dialogflow, or Amazon has their own service of for Amazon Echoes. So the platform, which is Google-owned chatbot development framework, it's called as Dialogflow, which I worked on. while I was working at Google. It is used for NLP. It's a software as a service based product, which means that you don't have to worry about the infrastructure. So it will run on Google's infrastructure, which obviously is like can be scaled to the whole world. So that's how the main advantage of Dialogflow is. So the main reasons why you should pick Dialogflow over the others is multi-channel supports. Dialogflow supports one-click integrations for more than 20 plus platforms such as Slack, Messenger, Instagram, or any messaging platform you have. Dialogflow has its support. With just one click, you can deploy a chatbot into that platform. The price, Dialogflow can be used free of cost if you are using standard edition, which is, I would say, more than enough to getting started with Dialogflow. And once you generate enough revenue, then you can move towards a more priced plans. The next main advantage is multi-language support. Dialogflow currently supports more than 14 plus languages worldwide, and more support is coming in soon. Um, so most likely that Dialogflow, if you have your model generated in English, it will automatically convert them into 14 different languages for now. And the more languages we get added, it automatically generates a language model for you. And the next is the best NLP. Dialogflow has the better machine learning in my experience compared to its competitor, even with less training data. So next slides. What are the building blocks of Dialogflow? So first, an agent. Agent can be described as the app that we create on Dialogflow, which holds the definition of intents, entities, knowledge base, etc. We can, the fun part is we can export agents zip file as well to Dialogflow, which I think it's really cool. Uh, Agent is like uh, an app which you will create is called an agent. And the next, once the agent is created, you create intents inside that agent. So intent is that what user wants to do is called an intent. That is the intention of the user. And famous saying by Alan Furstenberg is that intents are what user wants to do, but not what we want to do or what the information how we reply. So that's one really careful place where you need to figure out what user will use this chatbot for rather than saying what information you want to give to that chatbot. So intents contain many things like context, events, training phases or responses, etc. So once the intents are clear, then it moves on to the training phases. So now to the training phases where human part comes in. As humans, we are completely complex, and uh, we can say the same thing in numerous ways. That's what the beauty of the language is. It means that single thing can be described in many ways. For example, if you want to set an alarm, we can say that set an alarm for 6 a.m. Or we can also say that I want to set an alarm. Or also that can you please set an alarm for me? Which are three different sentences for a computer, but for a human, those are exactly same sentences. So these are called as training phases, which will be used to match what user wants to do to let the computer understand that all these kinds of sentences are have only one goal. And once the training phases are set, it moves on to the entities phase. For completing a task, we might need some data from user. For example, when you have a chatbot for flight booking, we need information from the user such as so what's your source, what's your destination, or what the date you want to fly. These are called as entities which the user inputs for your chatbot. And the next thing is fulfillment, which is kind of optional sometimes when you add additional logic to complete a task where so for the same example, when you want to build a chatbot for flight bookings, uh, you would want your you would want your chatbot to access other websites and see what available flights are there for the given source, destination, and date. Some flight booking API, calling some flight booking API. That's what fulfillment is. And next, once the fulfillment is done, it moves to response. That's when, after all the processings are done, which is till fulfillment, that's when a user will see a reply from the chatbot saying that, okay, for your question, this is my answer. That's how contents, you can edit those responses as well in Dialogflow, where it can tailor towards what your needs. So these are the building blocks from starting from how a user enters input to how he will get a response from Dialogflow back. So moving on to description of each and every phase, what happens right from a user entering a text into a chatbot to how a user gets a reply from a chatbot. The first one is user sends any text message or to a device or an app. Then that device transfers that message to Dialogflow, and then the message is categorized and matched with the corresponding intents which we created manually inside Dialogflow. And then for each intent, we will already have specific actions saying that for this intent, these are the actions you need to perform, for which are mentioned in the fulfillment and the intent phase described in the earlier slides. And next, for the external databases, if you have the optional fulfillment phase, for in the example of flight bookings, you call other websites of flights saying, asking for what are the available flights. And next, that website sends you all those flight data saying that these are the available flights to that intent. And next, the intents generate actionable data for according to different channels per the user. Then that actionable data goes to the output of the app, where the user will get an output saying that the output which is generated by Dialogflow. This is the whole process that goes through every chatbot which you build, no matter what the platform is. This is general feedback process which goes through from a user entering the input and getting an out response from the chatbot. So that's pretty much it about NLP, on what chatbots are and how you will be using chatbots inside your systems, and why you should use chatbots to improve your business use cases as well. As I said, you can contact me through the mails or the contact information inside the slides. So yeah, that's pretty much it from my side, and I'll be happy to answer any questions you have.
Yeah, thank you so much, Roy, for that amazing presentation over chatbots integration with natural language processing. As you said, now we're open to answer any questions the audience might have. Please, I would like to know if any of you have any questions, so I can read them and then Roy can answer them.
Yeah.
Yeah, so. Okay, so Juan here said, does Dialogflow use deep learning?
Yes, if you want, it does support deep learning models. If you want, you can use them they are at your disposal. If you want, you can use them, but I would say start with the classical machine learning approaches, and then if those models doesn't solve, then move on to the deep learning models.
Great. So then Nasser asked, which are the advantages or disadvantages from using platforms like Dialogflow instead of creating a chatbot with natural language processing from scratch in terms of cost, infrastructure, and maintenance?
Uh, it's more of how fast you want to develop a chatbot. So creating NLP chatbot from scratch would take you a lot of time, and it requires a scalable infrastructure, which is a very costly process. That's where a Dialogflow comes in, where it will use Google's internal servers to do all the heavy lifting for you and help you focus on the main parts of the chatbot rather than focusing on how to scale it for a global audience.
Yeah, I don't know if I mentioned that he also asked which what do you recommend from um, the question previously already mentioned.
So, if you are a beginner just starting through, then start going in a scratch process wouldn't be a easy task. The Dialogflow would be much more beginner friendly, but there are certain limitations in Dialogflow as well. You can't have intents which are nested, which are coming in the later stages of Dialogflow, which can only be done some if you have very complex requirements for your chatbot. Then having a NLP from scratch helps a lot.
Great, thanks.
So yeah,
Yeah. So you're finished. I'm sorry, did I
yes,
interrupt? No.
no.
Okay, great. Um, yeah, then Jaime will ask if he could train a software to recognize a digital signature to replace an ID number.
Uh, yes, I would say a digital signature. I'm thinking as you would need images of that digital signatures at different angles, and a normal classical model should work as I'm expecting if it's not a very complex signature. And to replace an ID number, yes, it machine learning approaches does work pretty good on that. I would say look at image recognition techniques or classification such as on MNIST data.
Okay, thank you. Then the next question will be from Miguel. He asked, what are the limitations for free Dialogflow?
Free Dialogflow, the limitations are, I'm not sure the exact ones, but uh, pricing gives you little more flexibility than the free versions have. And maybe there's a limit on how many intents you can add per app in the free version. Uh, and it must be unlimited in the paid version, and also the infrastructure, it is much more scalable when you have the priced model than the when you're using the free model.
Perfect. Then Andres would ask, what companies are providing natural language processing as a service?
There are many. As in, if it was 2013, there were only handful of companies which had NLP services, but now there are tons of companies which provide NLP as services. The famous ones, I would say, the OpenAI models, Hugging Face. Those are the ones which are leading, which provide NLP infrastructure and pre-trained NLP models for use cases.
Then I have a question. I mean, not my question, but somebody sent a question to me priorly, and I just
Okay.
wanted to hear as well. Um, this question is from Jorge. He works actually with us in the company as well. He asked that if you believe it's a good idea to train a chatbot to recognize slangs. I believe it's slang languages, like yeah.
Sign languages, I
Like,
believe,
yeah.
yeah, there is already an existing system which I don't know how good that model is, but I've seen models which interpret sign language and give you audio or a text as a subtitle. I'm not sure how accurately that works right now, but there has been attempts on that, and you can definitely do that.
Great. Any other questions from the audience? Okay, I think that's all. Then thank you so much, everyone, for joining us today. We really look forward to doing more content related to this type of topics in software and programming and, of course, technology. We were really pleased to have you join us as well, Rohit, today. And we will also like to invite you to follow us on Facebook, Instagram, Twitter, and LinkedIn. We post a lot of really nice material over these topics there. So we will appreciate your support and thank you so much for your time.
Thanks for having me.